Hi, my name is Bowden Kelly. I'm a program manager on the JavaScript and TypeScript team in Visual Studio.
And I'm Mats Christensen. I'm also a program manager on the web tooling team in Visual Studio.
And today we're going to be looking at modern web development in VS 2017 and some of the new things that we've done to make it even better. So let's just jump right into it. Before we get started, if you go ahead and download Visual Studio 2017 right now, you will get this workload chooser right here. And what we're looking for is ASP.NET and web development. And this is going to give you everything that you need to do what we show you in this demo, as well as everything you need to be successful with web development in Visual Studio. So with that in mind, we're going to go ahead and jump into Visual Studio. We already have a simple project set up. This is a ASP.NET Core application. And you can see we've got our controllers, our models, our views. We've got our www root with some CSS. We've got some JS. And we're going to be focusing mostly on the front-end JavaScript, the new features in the JavaScript development in Visual Studio. And so I'm going to open up this JavaScript file. And we have a really basic file. We have a query selector that's going to grab this greeting. We have a function that is going to update the text of the greeting. And then we actually call the function to make the change. And if we look real quick at what this application is, again, very, very simple. It's just a hello world because we're going to be focusing on the tools, the editing experience, and the help you get in the editor as opposed to kind of the platform. And so first and foremost, the biggest change in VS 2017 is the brand new JavaScript language service. And what this is it's the part of Visual Studio that supplies quick help. It provides IntelliSense. It helps with refactoring. All of the tools that go into making your editing experience great is provided by a language service. And each language has one. And in JavaScript, we've replaced the entire language service with a brand new one. Previously in Visual Studio, anytime you did JavaScript editing, we were running an entire engine in the background, the Chakra engine. And this would compute all of your JavaScript code on the fly. And so you can imagine if you typed in elm.textcontent, we would be computing that to see what members exist on Element. Going forward, we have a static analysis engine, which is provided by the TypeScript language service. TypeScript is a language built on top of JavaScript, and it uses types to kind of empower its editing experience. And what we did is we took the language service that powers TypeScript, and we made it process JavaScript as well. And this has a lot of benefits, some of which are performance related. You'll notice a much more consistent editing experience, faster load times, as well as more reliable IntelliSense, especially around things like callbacks and long-running loops. But you also get a much richer IntelliSense experience. What do I mean by richer IntelliSense? So if I look at a query selector, for example, and I look at the signature, you can see that I have some basic information here, but I also now have a type, and it's highlighted in blue, and it says that the selector that I'm using is a string. And so previously, we could not provide this information because JavaScript is a dynamic language, and it doesn't really enforce types, but now we can. And how does this work? If we hit F12, go to definition on this query selector, we will see that we are now in this .d.ts file. And this is a TypeScript declaration file. And what this does is it gives definitions to every single component, every single element, every single type in your JavaScript code. And so here you can see that we can have selectors that can be strings. We have a bunch of types here, all of which we never knew existed because we're in JavaScript, right? But behind the scenes, this is what's powering the entire language experience. And so let's look at what happens with something like jQuery. You can see we have jQuery.min.js here. And if we type $, you see that our editor already knows about jQuery. And we can dot off that and see a bunch of different methods and properties. And one of the new features in VS 2017 that's not just for JavaScript, it's actually for most languages, is the ability to filter your IntelliSense window. And so you can see down here that I can filter by properties by clicking on properties, or I can click on methods to click by methods. And they have really reasonable hotkeys. So Alt-M is methods, Alt-P is properties. And so you can very quickly find what you're looking for by filtering through these IntelliSense lists. And again, if I pick one of these, like Ajax, for example, and I go to definition on it, I'm again finding myself in this index.dts file where this one is defining the jQuery library. And so this is another interesting thing provided by TypeScript. The TypeScript community has spent a lot of time working on these DTS files, these declaration files, to define the types and kind of, you can see a lot of documentation in here for every single method and member in jQuery. And it's not just jQuery, it's actually available for a majority of libraries in JavaScript, 2,000 in fact, and it's growing every day. And so what happens is behind the scenes, the language service sees that we do in fact have jQuery included in the project. The editor sees that you have tried to use jQuery with the $, and it goes ahead and it downloads this .dts file and injects it into the language service. And this is very similar to, if you remember, /references or your _-references file. This file would let you get references in IntelliSense for the same kind of thing. This all goes away in the new language service, and it does it for you behind the scenes. And so I'm going to close this out.
So just a quick question here. Those two declaration files that we just saw here, they're not in the project at all, are they?
Exactly. We don't want to pollute your project space. We just want to use these files for IntelliSense. Now, if you're using TypeScript, you would want to include them in your project. But because this is JavaScript and we just want it for tooling, Visual Studio will cache those for you in a separate place in app data and just use them for strictly IntelliSense. And again, this is all kind of as needed. And so as you use more libraries, we will download more DTS files for you behind the scenes. And then, of course, if you remove them from your project, you will remove them from your cache, and you will no longer see IntelliSense for those libraries as well. And so, again, I'm now just going to use jQuery real quick to replace this document query selector with jQuery instead. And you can see that I can throw in a $. I'm getting the IntelliSense I expect. If I look at the query selector, I, in fact, have a string. I have this optional kind of context element, but I don't need it. And then you can see that it accepts a string container, CSS selector, and I can use that to update as such. If I switch over to if I save this, switch over to our window, and refresh, we will be good to go.
Right. Except for you forgot to update the, let's say, use jQuery.
That's right.
So we're going to use the text function here. And again, you get that very nice IntelliSense coming in from the TypeScript engine that powers the JavaScript tooling here. So like that. And now we should have hello world. So now we've basically converted our little app here to use jQuery instead of sort of the raw DOM APIs. That's very cool. I want to show us some other thing here. If we look at the error list, we can see that we have an error that shows up here, or a warning. And it's about that semicolon is missing. And it also states here that it comes from ESLint. So ESLint is a linter. It's probably the premier linter for JavaScript files. And basically what linting is, it's static code analysis that makes sure that we write quality code. And it's now built in the box in Visual Studio 2017. So that's really nice. I don't have to set up my own like pipeline of tools, like usually Node.js-based tools, but I just have it right here in the box. And if I click the error, it takes me to the place that I have the missing semicolon. I'll add it here, save the file, and we can see the error goes away. And there are a lot of rules that powers ESLint, and you know, out of the box you get some defaults that that we think are good defaults to have. But if you go up to Tools and Web Code Analysis, you can see here that you can edit your ESLint settings. And by the way, we have CSS and CoffeeScript linting as well. But if we choose the ESLint settings here, you can see they're all here. And they're all sort of the official .eslintrc file that comes with ESLint, the node module. But again, this all runs behind the scenes. There's no artifacts in your project. However, you can modify this file to your needs, but you can also have a copy of this file in your project. And that will always then win. So you can customize this per project, what rules you want enforced, and that's a very, very nice thing to have. And of course, you check that file in so the entire team, development team, adheres to the same rules. So let's look at this page here again. Now I want to change this. Instead of it saying hello, I'm going to say hi, and I'm going to save the file. And notice how the browser just updated, automatically.
Instantly.
Yeah, that's really cool, right? So I didn't have to go to the browser and hit F5 to see that little change. What happens here is I'm taking advantage of a thing that's in Visual Studio called Browser Link, and that's a WebSocket connection that goes between Visual Studio and any browser that you have that's connected to the project that you're working on in Visual Studio, basically. And that's a really nice API that has that WebSocket connection. We can now talk back and forth. And what I've done is I've installed Web Essentials 2017, and that takes advantage of that Browser Link WebSocket connection to provide a way for me to update the browsers basically when I save a source file on disk. So I make a change, I hit Control-S to save, and we see the change reflected immediately in one or more of my connected browsers here. And I didn't have to hit refresh. So this is a really nice productivity boost. I'm really happy about this. It makes me feel good. And now that we're talking about Browser Link, let's see here. This is the Browser Link menu that we see up here. And I also have something called Web Accessibility here. So I can say run now in all browsers, or run on page load, right? So it can run automatically, but I have turned that off. I say, hey, just run right now. And so we can execute that, and we can see what happens in the error list. We get a bug here that says, hey, make sure that the HTML document has a language attribute. So this is sort of a typical little error that we catch as we design the app. And that makes it very easy for me to go in and add that language attribute to the HTML element. I'm just going to do en right here. And we can execute the checker again, and we see now the error goes away. So what happens is that the Web Accessibility extension uses Browser Link to analyze the live DOM that's running in the browser, and it brings back any errors that it finds that violates any accessibility rules. So we no longer have to build our apps and then afterwards go to all these online checkers to help retroactively kind of fix issues with accessibility. We get a really good experience as we develop the product here or our website directly.
And you get those alongside your linting errors and your standard syntax errors all in one place, all in Visual Studio.
Exactly. So they just become part of your natural workflow of building a website, which is really nice. So that was all very cool. So let's close this down. There's an issue here that the audience might have noticed, and that is I'm using ECMAScript 6. This app, right? And so you can see that because we're using the let keyword instead of var, and we're using a template string right here instead of regular string concatenation. And while that works in the latest version of Chrome, Firefox, and Edge, it doesn't work in older browsers. Older browsers understand ECMAScript 5, but they don't understand ECMAScript 6. So in order for me to take my ECMAScript 6 and make it work in older browsers, I have to do something called transpilation. So I have to convert my ECMAScript 6 to ECMAScript 5. And there again, there's many different ways you can do that. One thing that's really cool about the TypeScript compiler is that it actually supports that natively out of the box. And I can take advantage of that. If I just right-click my site.js file here, I can go down and say transpile to JavaScript. Let's click that. That will give us a tsconfig.json file, which you right now see on the screen. And here we say, hey, compile on save equals true. So whenever I save my site.js source file, it retranspiles back into ECMAScript 5. It does that by creating an output file called bundle.js. And here's an array of my input files. So I only have one in this case, so that's easy to see here what's going on. But the output is in bundle.js, and it already created that. So let's take a look at what that looks like. It looks very, very similar to my input file here, but you'll notice that it uses var, and it uses simple string concatenation instead of a template string. So in order for me to take advantage of this, I basically just have to go into my HTML and change my reference, and of course you get IntelliSense here, to bundle.js. And now my app is running ECMAScript 5, but I didn't really have to do anything. I didn't have to add any external tools or anything. It just happens automatically for me.
So you get all the benefits of writing ES6 features. You get the productivity boost that comes with template strings and let and const.
Right.
But at runtime, you get the benefits of ES5, which is that it runs everywhere.
Exactly. So let's just run this app again. But this time, I'm hitting F5 because I want to debug this. And you'll notice that I'm using Google Chrome. And when you do that, you'll see that we now have Chrome script debugging. And so we're attaching the debugger and load the page right here. And so right now, the Visual Studio debugger is attached not only to the server side, the ASP.NET running on IIS Express, for instance, but it's also attached to Chrome itself. So that allows me to go in to site.js, not the bundle.js that the browser knows about, but site.js, which is my source file. Set a breakpoint. I can refresh the page, and you can see here the breakpoint hits. And I can use all the similar stuff that you're used to from debugging here, step into, step out of, and so on. I can go down here and look at the locals window. I can, let's change this to high, like that. And if I now hover, we can see that the value is high. And let's just run this. And so the browser now says, hi world. So I have this full fidelity debugging using source map. And let's take a look at what that means. Because when we created the bundle.js file, it also created a source map file right here. So if we look at bundle.js, it says, hey, my source mapping URL is the bundle.js.map file, which is located right here. And this is a standard. Let's format that here. This is a standard for describing the relationship between what the browser runs and what the source file looks like. And it's not meant for humans to read, so that's why it looks a little wonky here. But the machines understand it. That means Visual Studio understands it. It means all the browser developer tools understand it, whether it be Firebug or the Firefox developer tools, the Chrome developer tools, the Internet Explorer and Edge F12 tools. They all understand source map. And now Visual Studio does too. And I can do this for JavaScript files, but I can also do it for JSX. So if you're a React.js developer and you want to use the TypeScript compiler or any other compiler or transpiler, whether it be Babel.js or what it might be running in Node, as long as there are source maps, Visual Studio is able to do the mapping, and you can debug directly from Visual Studio, which is really powerful, right? We just stay in Visual Studio, we just write some code, we set a breakpoint, and we can just debug away without any context switching, and that's really, really cool.
And again, in this case, this is the tsconfig that is doing the source maps?
Right. It's the tsconfig. It has a lot of compiler options here. We can set all sorts of parameters on it, and as I said, it works for JSX files or TSX files. There's also you can write React.js using TypeScript. So both JSX and TSX, and of course TypeScript itself .ts, all compile in the same way, and you get the same options you can set, and they update on safe, and it's really, really nice development experience. And if we just stay with the TypeScript compiler like I do right here, we don't have to include all these other tools in our project to do that. So unless we want to do that for whatever reason, and there are plenty of good reasons, we don't have to, right? And so that feels really good. And because it's the TypeScript one, it has MS Build support. So not only does this work at design time, it also works at build time, let's say on a CI server, for instance. So really powerful stuff.
Excellent.
So let me close this down, and let's take a look at the JavaScript, because I was hoping that maybe you could help me fix this up a little bit. I feel like it could be a little better.
That's right. Another feature of Visual Studio 2017 and the new JavaScript language service is we replaced VSDocs with JSDoc. Some of you remember VSDoc, which was this XML-like format that lets you kind of add additional metadata to your functions. This has now been replaced with JSDoc, which is a standard in the JavaScript community. And it looks like this. If you do a /*, we'll template out the whole JSDoc for you. And you can see you can add a description here. So add greeting text to the page. And we can say the greeting text to update. And you can see we also have a type parameter here. And what this does is it lets you choose a type for this parameter. And so I can say string, I could say number, I could say whatever I want, and you can notice I'm getting IntelliSense here. And this is really powerful because what we can now do is look at where we've called this hello function and see that we now have our type inline. We now have a full description for this function. And we also have text, kind of flavor text for each parameter. And so previously, JSDoc and this kind of documentation was only really useful for decorating the area of code that you're currently looking at. But now this will flow through your entire code base, and you can get it on every single usage as well. And that's extremely powerful.
That's really cool, like in a team. All your team members know your intent of the code, and so when they call it, they can see exactly how to use your function.
That's right. And when we talked to developers, a lot of them hated writing documentation for JavaScript because they felt like it was stale and it was kind of useless. It kind of lived and died by the function. But now we kind of slurp that up into the language service, and we pass it through your entire code base, and it powers really all the tooling if you put some effort into it.
Right, and it's an industry standard, so you see this used in a lot of places.
That's right, and it's not going away.
Yeah.
Some other things that we can do now with this language service and this kind of extra information we have is we can do all of the standard kind of refactorings. We have rename as we would expect. We can go to definition. We can peek definition. We can also find all references. All of these things that you would expect from any language in Visual Studio, you can now do for JavaScript. All of this, again, is powered by TypeScript. If you're noticing a trend here, TypeScript is the driving force behind all of these productivity tools. And you'll notice that even though we have now put this string parameter or this string type on our parameter, even if we call another type here, JavaScript won't stop you, because then that's what you want from JavaScript, right? It's a dynamic language. You can pass in kind of whatever you want to a function. But if you are interested in that extra type checking, we don't have time to talk about it today because we're focusing on JavaScript and kind of those features here. But I recommend you check out typescriptlang.org, and you'll find a lot of information on how to start using TypeScript and get more productive with your JavaScript in Visual Studio.
That's very cool. So I want to show a few things here. A lot of people are moving into writing a lot of JavaScript-based web applications. And so, of course, we see Angular and Angular 2 being pretty popular, right? We have React.js, both like in its JavaScript and also in its TypeScript version. And we have great support for all that. So Angular 2, for instance, is TypeScript, right?
Right.
And so obviously we have the premier TypeScript editing experience right here in Visual Studio. So you're going to have a great experience with that. But then we have a newcomer to sort of the single-page application frameworks, which is something called Vue.js. And I just want to call it out because I think it's kind of cool what we got here. So I got a Vue file right here. And notice we get a nice logo. This is the Vue.js JavaScript library logo, right? And they use something called .vue files, V-U-E. And in the past, so before we had this brand new JavaScript and TypeScript editor, it was kind of hard to use Vue.js because we had some issues with certain ECMAScript syntax things. And I just want to make sure that it's out there, that this now works. You are completely unblocked from doing any of this. And not only that, you get a great experience. So you can take any Vue file, open it as an HTML file. Or if you have Web Essentials installed, that's taken care of for you. And of course, you can use the module export import syntax. That was one of the things that was problematic before, but not a problem for the new JavaScript tooling here. But you get more stuff. You even have like IntelliSense specifically for Vue.js showing up. And also, if you have custom directives that you are creating in Vue.js, they will also show up as HTML elements and attributes, and however you define it in Vue.js. So I just want to call that out because it really is now in 2017. It really is a premier way to work with modern web applications and frameworks, and you are completely covered in anything from ECMAScript 6 and even 7 features, and we have a great compiler story as well for all of this.
That's right. If you look at Vue and you look at React and you look at Angular, they're all starting to mix the boundaries between HTML and JavaScript and CSS, and all these things are starting to be found together. And so you really need to do all of them kind of in one place.
Right. And so it's really cool. Again, install Visual Studio 2017, get the web workload, and try out Web Essentials, which is a free extension. You can works on the every version of Visual Studio 2017, be it Community or Pro or Enterprise, and you get all these extra benefits. So I encourage you to try that out. And
all right, are we ready for questions?
we are ready for questions.
Fantastic. So there's a couple of questions. By the way, I'm an old school like WinForms guy, and the first time I started to do like a modern web application with JavaScript, I did not even know where to start. And so thank you for the work you're doing. It's definitely helping at least me becoming a better web developer. Here's some questions. Where does TypeScript, this is from Frederick, where does the TypeScript type declaration file that powers JS IntelliSense come from?
So I mentioned that the DTS files, those declaration files, are made by the community. It's mostly a community-driven effort. And so when we looked at jQuery.dts, that file was written by several community members, and it's hosted on a GitHub repo called Definitely Typed. And so if you search GitHub Definitely Typed, you'll find thousands upon thousands of TypeScript declaration files, and that is the source that we use to pull DTS files into your code base.
Awesome.
But the mechanics of getting them in is it correct that it's using NPM to bring them in?
It is using NPM to bring them in.
But you don't see that. It happens like behind the scene in some folder that has nothing to do with your project or anything like that.
Exactly.
It's an implementation detail.
It is completely separate from your project in every single way,
Right.
So that you don't have to deal with the tooling requirements for getting those DTS files and maintaining them.
Right.
It all happens for you behind the scenes.
One of the things that I saw what I'm worried about is Visual Studio like circumventing the standard tools like NPM, or if you're using Grunt, Gulp, or any other kind of thing, like, or is it just using the tools under the hood? That's a question that I've always had.
Right.
It's just using the tools under the hood. If you at any time want to replace those things in your project, if you want to drop a node modules folder in your project with your own typings, we'll pick up on those. And you can use all of those things like Mad said, the grunts and gulps and all of the node-based tools. We have support for all of those, but under the covers, we do it for you to not expose you to all that complexity up front.
Right. And so if you want to use, so Gulp and Grunt support is actually built into Visual Studio. So if you're using those frameworks, you get that sort of for free. So if you have a Gulp file JS, that will be automatically picked up. You can run individual tasks right from Visual Studio without dropping to the command line. You can bind Visual Studio events like Project Open or Build to then execute certain Gulp tasks. And so Grunt and Gulp, they're built in, but there are extensions out there that use the exact same underlying API that the Gulp and Grunt integration uses. And so there are extensions for Webpack, for Rollup, for Brunch, Broccoli, NPM scripts, and I'm sure I'm forgetting some here. But
I'm sure you are, because I mean the web space is moving so fast with the kind of toolings. I just recently learned about Webpack. I'm moving a little slower. And so now even Grunt and Gulp may be older. And so it's cool to see that, can people build their own extensions into Visual Studio to take advantage of these new modern tools?
They definitely can. There are actually project templates available. So if you go to the marketplace, the Visual Studio marketplace, there are actually project templates available. So you can say, file new project and select a task. It's called a Task Runner Explorer extension. And so that will scaffold everything for you and just have to fill in the blanks. All the ones that I just mentioned are all on GitHub, all open source. So they are a great way for you as well to look at, how to do these things. And what's really cool is that Node itself, Node.exe, so a lot of these tools are based on Node. It's actually shipping with Visual Studio itself, so you can run all this without installing Node, which is kind of cool. You can if you want to, of course, and a lot of people do, but you don't have to install Node.
So I'm going to go rapid fire really fast. Any update to compiling Sass and less files?
Yes, so Web Compiler, the extension is available for Visual Studio 2017, coming with Web Essentials. There is a new extension that's sort of an alternative approach that I just released called Less Compiler, which is a lightweight, no config unless you want to kind of approach, living somewhere in between what Web Essentials 2013 used to do and what Web Compiler does, somewhere in between, and you can go either way depending on your mood.
All right, last one. Is BrowserLink an alternative to Gulp Live Reload Webpack for use with Angular React.js projects to improve productivity?
Yes and no. No. I think no in the sense of those specific frameworks. What we want to use there is, so we're working on a bridge, something that makes it really productive, that you can run all your Angular and React and Vue.js and all this sort of good stuff that has live reload and hot module replacement. Have that actually work with IIS Express. So your F5 or Control F5 in Visual Studio also boots up IIS Express, but also works with the hot module reload and all that sort of stuff. That does not use BrowserLink, but you get the same sort of benefit. BrowserLink is still there, so that if you have extension that does other things, you can still make the communication as long as you have an ASP.NET. As long as the app itself is ASP.NET, you can use static files and all that sort of stuff, HTML, as long as it runs in the ASP.NET process.
Awesome. Well, thanks so much for spending some time with us. Coming up next, Azure Development in Visual Studio 2017. Remember to get your questions in using hashtag VS2017, and we're going to start right over there.